All right, so hi everyone. I'm really excited for being here and sharing with you some of the ongoing work in our research group related to teachable interfaces that can have implications for accessibility and inclusion. So every day we interact with machine learning applications, and we do this often while emailing, checking our social media, or anything actually we do with the so-called smart devices. Through every click, scroll, and like, we shape these technologies, but we don't do this through a panel of settings or controls. We do it unintentionally, as our interaction breadcrumbs are being captured, interpreted, and repurposed. So to us, the end users, these models remain black boxes. Now, you may wonder, what would it look like to give end users an experience of training artificial intelligence in their everyday technology? And this is what teachable interfaces are, what Bjorn Karman called a shift from being a passive consumer to an active, playful director of domestic technology. And this was in 2017, when the same year that he was helping Google deploy the teachable machines that they called an AI experiment that makes it easier for anyone to start exploring how machine learning works. I'm going to show you an example. So the interface at the teachable machines allows you to teach a simple computer vision model using your camera, and you can do this in your web camera live in the browser without having to do any coding. And the idea here heavily borrows from the end user programming paradigm. And people start doing different things with it. I'm going to play the video here today, and this video comes from Alexander Chen. So he has already trained the teachable machines. I'm not going to show you the training part, but I'm going to show you when he tests it. He's already trained to recognize 3 types of input. One is an origami bird, second one is an origami ghost, and the third class is none of the 2, so no origamis. And more so, he has mapped these 3 classes to 3 particular sounds, so a bird sound, an organ sound, and like just quiet. And so as I'm going to play this, I want you to kind of like remember those. And during now testing, he's able to show you an interactive sound experience just by showing different origamis to the camera and triggering these sounds that he mapped. So let's play that. All right, so I hope you enjoyed that. Get my control here. Right, so just a year before Google actually released the teachable machines, our group had also been working in 2016 on this idea of teachable interfaces, but with a different motivation, the one that has related to accessibility. So this is a collaboration with Chris Kitani, Jeff Bigham, and Cheiko Sakawa. At the time, I was at Carnegie Mellon University. And there we were asking questions like, what if blind people could take photos of objects that they care about, and they can train mobile phones to recognize them, right? Of course, the reason why we could do this is because approaches like transfer learning at that moment were ripe ideas. So, typically, if you want to develop any, deep learning models, you need tons of data to train them on. But with transfer learning, what we could have done is that we could pre-train our models with data, images that we already had available, and then allow the blind users to come in and fine-tune these models for the classes they care about, so the objects that they want to recognize, but they don't have to provide now like tons of data. They could provide even like 30 examples, and then the system hopefully would work. Now, we had looked at VisuWiz. This was one of the first accessibility applications out there. As a blind person, you could just take a photo on your phone and send it to sighted crowd workers and could tell you what is, they could answer questions that you had about the picture, like what is being shown there. And so here is a network that we generated of term occurrence. So we looked at the questions that blind people ask about their photos, and then we visualized it in a way here. So we saw that most of the questions were things like, what color of a shirt is this? What color of shoes, or like what pants are these? What socks are these? What kind of a package this is? What flavor, right? So I'm going to narrow down on one of these terms, which is soda. So here are questions associated with the term soda. That they knew already just by touch that this is some kind of a soda can, but they wanted to know what specific kind of soda can it is. And then they tried to take photos for people to answer. Now, if you were to build an app to help blind people to do this kind of task, it would be very challenging because we're talking about instance level of recognition here, right? They can tell it's a soda can, they can tell it's a cup, they can tell it's a bottle. What they want to know is like what kind of, for the specific information. And we can't build a machine learning model that can recognize all the possible instances of objects out there for all blind people. So we need some kind of personalization. And this is what teachable interfaces can do when we brought them in. Now, of course, it's not like, there were no other alternative solutions that blind people already have adopted at this point, right? One was, of course, having some sighted help, but, there are other solutions like putting some braille labeling on the objects, and other solution was more ad hoc, like, just don't buy 2 kind of sodas in the same week, or just like, use some kind of, organizations that will help you to recall every time you grab something, what it is, okay? But with applications like the one that we brought, the Teachable Object Recognizer, here is one of the comments that we heard from one of our blind participants. This is P5, a 60-year-old blind woman. After she experienced our work in prototypes, she's like, I want one today, and it'll be so much less complex than what I already use right now. You're just gonna go boom, boom, and we'll have it in its repertoire, okay? And I'm going to show you another example from another participant in our study that she, was thinking like, well, what can I do with Teachable Object Recognizer? She already had some solution around her, products, but she's like, I would love to teach it to recognize my t-shirt. She had a huge collection of CAT event-related t-shirts, and it was very important for her to know every day which of those she was wearing. And she's like, okay, I'm just going to train my phone to be able to tell me instead of having to call family members and show a video of me wearing it so that they can help me every day. Right. Now, I'm going to focus on that aspect of like boom, boom, taking the photos and have it in its repertoire. It's not that easy. It turns out there are 2 challenges that we face there. So the first challenge is a unique challenge to accessibility when we're talking about these teachable interfaces, because often they require the same skills and training that the model aims to complement. In this case, it's vision. So if you are a blind person and you can't tell what kind of photo you are taking, how are you going to be able to train your camera to recognize what it is? Okay. So a lot of our work since 2016 has been like, how can we support blind people to provide good training examples? And so I'm showing here a little bit of examples of photos taken by blind people during a training phase, for example, training Doritos and some like Ritz Beats. And you can see here problems like, the objects being partially included, cropped, or not included at all, or just the back of the object being there, which just doesn't have discriminated features at all. So, the algorithm won't work very well. So to address some of these challenges, some of our first work was, well, can we build systems that can help, they can learn perhaps where the object is located just by looking at its proximity to the user's hand. So maybe that is the object of interest. And then maybe we can provide real-time feedback to blind users through sonification and vibration. And then this was well received by our participants. Another approach that we are currently working on, so this is under submission, this work, is we are thinking like we can build models that can estimate in real time descriptors about the training example. So kind of alt text, but it's not going to tell you the same thing, like this is a soda can, this is a soda can, but it's going to tell you things that are meaningful to the training task. Like it can tell you things like, your object is too small in this particular photo, or things like the object is cropped, or things like, the photo is very blurred, or your hand is included in case like, you don't want your hand to be in there, just to make the machine more generalizable to recognize without your hand in presence, right? And we can also be able to generate descriptors with mixed, actually, performance, but descriptors that are at a higher level, not just at a, at the photo level, but at the set level, right? So things that you can only obtain by doing a visual inspection of your training data. Things like, there's only a small variation here on your object across the size of the object. You only have a small variation in the perspective. You're only showing one side of the object. So maybe you will not generalize very well next time that you try it. Or things like you don't have any variation of the background, you're just training it against your table. And then maybe next time you want to ask your phone against the couch, it might not work. Okay, so things like this. Now, it's not a surprise, perhaps, with such real-world application to see Teachable Object Recognizer from our 2017 published study receiving some attention from industry. And so we, a year after we had Envision AI, a Netherlands-based company, incorporating this feature in a public beta mode in their app. And IBM in 2020 and others built on top of this work, also considering other approaches to help with that first challenge of having good photos if you are blind and you can't see the photos. And more recently, in 2021, Microsoft released a very awesome data set for promoting more work in this area. It's called the Orbit data set. And we might hear from Google Lookout soon, I'm not sure. But many of our PhD students have been working in some of these companies. Now, one challenge that I talked to you about is how do you get good training examples if you can't see the photos? Now, what happens when you have no expertise in machine learning? How can you give good examples if you don't have an experience? You don't know what the machine works and what does it mean a good example for the algorithm? So here we ask 100 sighted people in a crowdsourcing studies to take their phone and take photos of 3 objects in their everyday house, and then just to train them. And we give them some incentives like a payment scheme to be like, okay, you want this model to be robust and you're gonna be able to train, test it, and then retrain it again. And so when we're looking at their teaching strategies, we observe them mainly tend to teach with clear representative examples. So they have the logo in there and like a very visible part of the object. Again, these are sighted participants. So this is promising. And some of them do tend to incorporate examples that are closer to the decision boundary. So we have 77 out of 100 diversified their training examples, and more than half, without being prompted at all, mentioned that diversity is a good thing. And it's important in their training. And so this is promising. Now, when we look at work from neuroscience, we see that Plenary and Gauthier say that if you're a human and you want to recognize an object, you are actually pretty good at generalizing across the size of the object, if it's zoom in or zoom out, across the location, if it's on your couch or on your table, the viewpoint, if it's rotated a little bit, you still can tell what the object is, and the illumination. It's interesting that we find that participants, these are people that don't have a machine learning expertise, but they also try to do their models generalize across these 4 dimensions, right? So 65 of them incorporated variation on object size, 39 of them in object location by placing the object in different places, 63 in terms of viewpoints by rotating their object, and 19 by changing the illumination. Of course, only 11 out of 100 did all of the 4. Now, when they go to testing, unfortunately, all these things about diversity were forgotten. They test the models to see they're robust with exactly, very much similar examples. And you can see here examples from the same person during the training and the testing. And of course, it was no surprise to see many people want to change nothing about their models. They were satisfied with the performance, or they were like, I don't know what to do to make it better. Okay, if we're looking at some of these misconceptions, I'm going to highlight 2. One is consistency. 23 people did not include any kind of variation in their teaching set, and whatsoever, right? Of course, it's good to have consistency in your training data when it comes between, your training and your testing, but within your training, you need some kind of diversity, right? And so this is what P6 said. I figured I needed to be consistent when I took the picture, so it looks similar. So this participant provided 30 times the same example to the algorithm to learn it. Okay, another misconception comes with their assumptions about what AI is able to reason about. So when they tried putting, training examples like, okay, I'm going to show the box, I'm going to show the inside, I'm going to take the content out, and then, so the algorithm knows this is the same thing, which may or may not work. So in a nutshell, we find here that it's critical to account for non-experts teaching strategies, help people better craft their evaluation examples, and anticipate common misconceptions when we're designing these interfaces. All right, so I believe that by enabling end users to be playful directors of AI-infused technologies, teachable interfaces can have deeper implication for innovation and AI literacy, and we're really scratching its surface. So I hope I gave you a glimpse of the potential that teachable interfaces have for accessibility with the Teachable Object Recognizer project. You can see a demo of it today in the poster session. But we also, with a wonderful group of collaborators, many of whom are here today, we're also looking into implications related to inclusion, such as having projects like teachable activity trackers for older adults using their smartwatches. So how can we have older adults train their smartwatches to recognize activities that are meaningful to them? They might be walking or running, but beyond that, it could be gardening, bird watching, or yoga. And then we're also tinkering a little bit with the potentials for these interfaces for creativity and education. And a lot of my colleagues here are in the room. By exploring these interfaces together with autistic and neurotypical youth, with some of this work already being out there. So we hope you'll stay with us on this journey as we expand to other potential implications in terms of privacy, explainability, control, and trustworthiness. And broader machine teaching paradigms. Wrap up. In today's talks, I really focus on some of the most recent efforts in exploring teachable machines and teachable interfaces for accessibility and inclusion. I want to highlight here the amazing past and present collaborators in the HCIL lab and beyond that contributed here, and of course our funding agency. And I'm highlighting here some of the people that are already today here in the room, so you may ask us any questions. Thank you.